morning, guys. I'm really sorry for the delay, and I welcome you all for this session on switching, CCNP switching. And I'm Sanal, and I'll be your mentor for the next 20 days. Okay. So most of you have already completed CCNA. That's why you're here right now. So this paper on CCNP switching is all about whatever you have studied in CCNA. I'm going to take you to the next level. Okay, we're going to move on and I'll teach you how to optimize and troubleshoot your switching environment. That's what we're trying to do with this module. Okay. So we have a 20 days period. It's actually a short duration, but we have lots to cover up, etc. And most of you are already aware with Packet Tracer Simulator, right? You've worked with Packet Tracer. Have you worked with EVE-NG? All of you? EVE-NG, next generation? No? Okay. So that's another software, just like Packet Tracer, but more advanced version. So you have to get it installed today itself from the admin. Okay. Mr. Avanish, you must know him, right? Yeah. Take his help and get it installed on your system. Most of our labs will be performed on EVE-NG. So that's the reason. 1 second. And this, yeah. Okay, that's the idea about this program. So basically, we'll be talking about Catalyst switches. Now, so Catalyst is the brand name created by Cisco, right? Cisco has Cisco has other brand names also. There are Nexus switches and all that. But we won't cover Nexus switches in this paper. We'll only be talking about Catalyst switches, L2 switch, L3 switch, how they function, etc. Right? You would have covered modules like VLAN, how to implement VLAN in your environment, and spanning tree, how the STP removes loops from a network. We'll be talking about that also here, but at a higher level. So make sure you brush up your fundamentals, right? Some questions will be asked today on VLANs, what you have learned, okay? And on STP, spanning tree protocol. And then in switching, you would have covered port security, how to implement port security for securing ports based on MAC. And then you would have covered, have you covered VACL, VLAN access controllers? Yes, in the good, very good. So you have done VACL, you have done, no, not ACL, VACL, not RACL, router ACL, VACL on an L2 switch. Have you done that? No, okay. That what you have learned is RACL, router ACL. Right? You have learned the router ACL. There's something called VACL, which you'll study. VLAN, ACL. ACL implemented in a VLAN environment, right? So private VLANs you'll be studying, etc. You'll also be, you have studied ARP, right? ARP? Yeah, great. So ARP is a very, very important topic for understanding packet flow, how data flows in the network. So that also will be discussed. Okay, we'll talk about first stop redundancy protocols. Have you studied HSRP, VRRP, GLPP? Yes, very good. So we'll be covering that also here in more detail, etc. So let's begin today's session then on, yeah. So let's see what next I can. Yes. So we'll start with an L2 switch. What is a layer 2 switch? Okay. So these are some points many of you would know. So we'll just recap on L2 switch. What is an L2 switch? Very important to know what an L2 switch is. So L2 switch is an intra-networking device. It's an intra-networking device. What does that word intra-networking means? That it allows you to communicate within the network only. Within the network. It allows you to move traffic only within the network. Doesn't go outside the network. That's what the L3 switches do. That's what routers do. Inter-networking device, right? So L2 switch is just an intra-networking device that builds a LAN for me, a local area network, right? I use this to build a simple network. Okay. It operates at the data link. It's called L2 because it works at the OSI layer 2. You all are familiar with OSI layers, the TCP/IP layer, right? The second layer of OSI is referred to as the data link layer. So, and it operates at that particular point, right? And there are L3 switches that can operate above, etc. There are higher layer switches also. And it's an access layer device. Now, what does that mean, access layer device? It provides access to devices. You can connect almost any device to an L2 switch, right? You can connect not just your laptops and PCs. You can connect a printer. You can connect a server, routers, other switches, firewalls, load balancers, IPS, IDS, IoT devices, right? A lot of devices you can plug into the device. So it's providing access to the network. It's an entry point to the network. Very simple. You want to connect any device to an existing network, you need an L2 switch. The moment you deploy an L2 switch, you plug in your products, like IP phone, IP camera. A lot of devices are out there, right? You plug in. So that's what an L2 switch is. It processes framing information and not packet information. When L2 switch receives traffic, right? The traffic contains a lot of headers. OSI, right? Or a lot of headers it contains. It contains headers such as you might have segmented like TCP headers, UDP headers, followed by IP headers, followed by frame headers, etc., etc. A lot of headers, trailers, and all are part of your message, right? Your L2 switch only looks at the frame. The L2 switch only looks at your frame. Now, what does that mean? Let me just give you that idea. Okay, let me just Let's see if I can show you a pic. No, okay, wait. Right, I'll do one thing. Let me just draw it for you. See? So let's say I have a switch. I have a switch. Okay, an L2 switch, which we are talking about now, an L2 switch. The L2 switch receives traffic from various devices. We know that. Now this traffic is encapsulated. What does that mean? It comprises of many headers. Right? A lot of headers, etc., and all those things are part of this traffic. So whenever data is being received by this L2 switch, whenever data is being received by this L2 switch, suppose a message is being received, it carries several headers in it. Right? Several headers in it. Lots and lots of headers in it. Right? The outer header is called the frame. The outermost header is known as the frame. Right? The outer header, the final header. There should be a final header, no? Final header, that's called the frame. Right? Inside this frame, if you open the frame, if you peel open the frame, you will see the IP header. You will see the IP. We call it the packet actually. Inside the frame is a packet. Packet is made up of headers, etc. All that, right? Inside the packet, we have something called the segment. Right? This is the story of encapsulation, OSI, right? So the L2 switch only looks at the framing information. That's a very critical point. When traffic comes in, the message will contain IP addresses, port numbers, a lot of other information, sequence numbers, etc., etc. It doesn't look at any of this. It just looks at the framing information. The framing information contains, we'll talk about that now. The framing contains majorly the MAC address. So an L2 switch looks at the MAC and then makes a decision how to move the data. That's what they do, right? It's all about looking at the MAC and moving the data, not IP. IP is there. It's fully hidden. Right? It's fully encapsulated. So its knowledge, L2 is only intelligent enough. It has been designed to only read the framing information, not more than that. Okay. So that's what we'll talk about it. It will be part of our conversation today. So please remember, it doesn't look at packet information. What is inside the packet? We have other segments, datagrams, etc., various things. Maybe a TCP segment is there or a UDP datagram is there. And inside that, other HTTP headers, upper layer headers, a lot of things. It doesn't look at anything. Only outer information. That's called framing information. Look at that. Find the MAC address. Typically, the destination MAC. Scan a table. What is that table? MAC table. Looks into the MAC table, finds the exit port, deliver. Finish. That's the story of L2. But to do all this, it has special chips. That's called ASIC. An L2 switch is known to be really fast. Okay, it's much faster than a router. Can you believe? Router is more intelligent than an L2 switch, but an L2 switch is more efficient than a router because of this special chip called ASIC, application specific integrated circuit. So this is part of the motherboard of the. If you have ever opened a switch chassis, if you ever opened it, you would see these chips installed on it. And most of these chips are designed to. Some of these chips handle various other aspects. For example, some of them handle QoS, quality of service, how to prioritize traffic. Some of them handle your packet filters, ACLs. Some of these chips are into managing the MAC table, lookups, looking into the MAC table. No, ASIC is it's not the CPU. There is CPU. There is also a CPU inside the switch. Okay, along with the CPU, these are helper chips, right? So when traffic comes, the ASIC is the one that looks into the DMAC, scans the MAC table, finds it. It's so fast, less than a second. You can't even imagine the speed. Like that, traffic comes out. So the speed of the L2 switch is the ASIC. Application specific integrated circuit. It is the ASIC that makes everything fast. Sending data at higher speed. That's the whole story of ASIC. So when you talk about an L2 switch, when it receives traffic, right, it can handle various kinds of traffic. Unicast, multicast, and broadcast. You send unicast traffic to the switch, what does it do? It will send it out to one particular destination. Unicast means one-to-one. Okay. You send multicast traffic to the switch, it can send to a group, a selected group, right? Broadcast, it can send to all devices. So very intelligent device. It can handle various kinds of traffic, unicast, multicast, broadcast. We use the word frames. That's the right word to use. See, many of us tend to use the word packets. Even when I was a student, I used to use the word packet. Packet is the terminology used for routers or L3 switches. The correct terminology for L2 switches, frame. Inside the frame, packet is there, but it's hidden. It doesn't process packet information. Are you getting what I'm saying? So it does unicast, it can perform unicast, multicast, and broadcast. One important point I would like to share here is this multicast that we're talking about doesn't happen by default. The switch cannot multicast by default. Come down. Can you see this? It implements IGMP snooping and CGMP snooping to handle multicast. So this part of the story, the multicasting, is not performed by default. If you send multicast to the switch, you know what it will do? It will broadcast. By default, an L2 switch cannot understand multicast. It knows unicast, broadcast. That is true. You send unicast, it will unicast. You send broadcast, it will flood. It doesn't understand multicast by default until and unless you set up features like this. IGMP snooping or Cisco Group Management, CGMP. Until unless you set this, your L2 switch cannot handle multicast traffic. It will just behave like, no, multicast. What is this multicast? I don't understand. So what I'll do? Broadcast. This is the idea. That's the idea of the L2 switch. So please remember that, etc. about the unicast, multicast, and broadcast concept behind the L2 switch. So whenever somebody asks you about the multicasting, please remember these two features. Any one of this is Cisco's proprietary feature. This is standard. Suppose you have non-Cisco switch, right? You can use IGMP snooping. Both these switches enable you to handle multicast. Probably you'll learn this probably the next level, multicasting. That time you'll learn this. So this is just written for you, just to make you understand. Okay? Operates in half full and auto negotiation mode. A switch can operate in half duplex. Half duplex means you can program it actually to operate in half duplex if you want to. Half duplex means that you can send and receive at different timing interval. You can't do it at the same time. If I'm talking, you cannot talk. If you're talking, I cannot talk. So it can behave like a half duplex device. Yes, a very good example walkie-talkie or hub. That's the network device hub, right? A hub is a very classic example of a half duplex device. In a hub, the rule is very simple. Devices cannot talk at the same time. Right? If two devices talk at the same time, it will result in collisions. Exactly. It will result in collisions. Some collisions will create drops in traffic. Right? You'll have a bad performance. That is one of the reasons why hubs were replaced by these L2 switches. So initially, when networking started off, after the bus topology, ring topology, and all these topologies, we had something called the star topology. Right? That's when the hub was actually introduced. It became a very famous product. But the drawback about a hub was that it was half duplex. It wouldn't let two people to talk at the same time. Imagine all of you want to browse internet. I am a hub. Only one of you can do at a time. After you finish, I give you turns. Like there's a timer, you know. I start giving you timers, etc. Simultaneously, you cannot. Switch can do that. So switch can operate in full duplex. At the same time, you can send and receive traffic. Same time, you can do that. All of you together can send data to me. Switch. Hub is like, no, sorry, you cannot send data to me. And there is something called auto negotiation. That's another cool feature of a switch, right? What is auto negotiation is? It's a feature you can set on a switch. What this feature does is it will adjust itself according to the receiving end. For example, let's say this is a switch, right? This is a typical L2 switch. Yeah, 356. It's an L2 switch. So you have an L2, right? It's actually L3. Sorry, 3000 series L3. It's an L3, not L2. But you can program it like an L3. It can behave like an L3. It has a MAC table, right? So imagine this is an L2 switch, right? An L2 switch. And this switch is being connected to a hub. Assume there's a hub. You have a connection to the hub. Hub is half duplex. Switch is by default full duplex. Now imagine I made a connection from the hub to the switch. A device which is full and a device which is half. What do you think will happen? He's like, if I'm talking, you cannot talk. He's like, I can talk and you can talk, both. What do you think will happen? If I connect a wire and I force communication between these two products. Pardon? Collision, excellent, very good. Exactly right. Collisions will arise. These two devices, the traffic will start colliding with them. So there's a feature called auto negotiate. I can program this. Where what this feature can do is it can figure out what the hub's mode is. Is it in half or what is the mode of the device? If it sees that, oh, you're in half, I will adjust myself to half. If you're in full, I'll adjust myself to full. That is auto negotiate. Very cool feature. Many network engineers program, or by default, when you buy the product, it's programmed to auto mode. So that I don't care what the other end. If you're half, I'll become half. If you're full, I'll become full. So no collision. So basically, the switch is known to be collision free. Wow, fantastic product. Hub was prone to collision. You can't help it. The product was designed like that. Switch is collision free thanks to all these cool features, auto negotiation. So an L2 product is fantastic in this manner. And the most amazing thing about this L2 switch is the MAC table. This is why it is superior to a hub. Hub never had this MAC table, also called the CAM table, content address memory. That's a special memory actually, where the MAC table lives. Inside the switch, there is a memory chip called CAM, content address, like how we have RAMs, right? In our laptops, etc. We have something called CAMs. So the MAC table lives in the CAM. And you know the story of the MAC table. The MAC table contains typically the MAC address, the interface names, and maybe the VLAN numbers, right? Which VLAN you belong to, etc. All these kind of things, right? Let me just see if I can. Yeah, so let's just so let's just see. I've just designed one topo for you guys. Just a small overview over this. Okay, if it open. Yeah. Right. So let's look at this. Right? You can see it. Can you see it? So, what are you able to say? Zoom it. Okay, that's too much. Now, okay. Just a second, 1 second. Yeah. So now it looks more clear, right? So what you can see here is a switch acting as a LAN builder. Typical L2 switch. Can you see various products connected? From the desktop to the L3 switch to routers, printers, firewall servers, wireless laptops, via access point. A lot of products are being connected. So we call this a LAN. Also, we refer to this as the access layer of your architecture. Yeah, and it's called the access layer of the device. So we know that that switch has a MAC table in it. There is something called the MAC table in it. Right? Does anybody know the command to see the MAC table? Show MAC address. That's all? Pardon? Correct. You're incomplete. What is the full command? It's very important to know the MAC table command of the switch. Tell me. Show MAC, correct half command. Tell me full command. Huh? Why you want to do? Huh? No. Show space MAC space address hyphen table. This is the command. Nobody is there in the notes. It'll be given to you. Right? This is the command to see the MAC table. You must know because I guess you'll be going into routing later, no? Routing, etc. You should remember this is very fundamental product. You should know about the MAC table command. Enter. There you go. That's the MAC table of the switch. You can see the VLAN column identifying which VLAN the devices belong to. As of now, no VLANs have been configured. So all the products are now in VLAN 1 by default. You know that, right? By default, it's VLAN 1. The MAC addresses of all the devices have been learned. We're going to see how the switch has learned this. It has this learning mechanism, right? It's very intelligent. It can learn. See, all these are MAC addresses of all these products. So if I just move my window this to the right side, yeah, there you go. Can you see that? How many entries do I find here? 1, 2, 3, 4, 5, 6 entries. How many devices do I see? 1, 2, 3, 4, 5, 6. One more it has to learn. So one thing about the MAC table I want to tell you is that these entries are not permanent. If devices don't talk, these entries get flushed. So that's why I didn't see one entry. Now I'm going to make them talk. We should see all the every device's entry into this. But for now, just analyze the table. It is typically made up of a couple of entries, which VLAN the devices belong to, which port the device connects to, the MAC address of each device, and how the MAC has been learned. There are two ways to learn the MAC. One is static. Manually, you can build the MAC entry, MAC record. Why? We're going to do that. We're going to learn all that. Why to build the manual entry? What is the benefit of doing a static MAC record in the MAC table? Dynamic is auto learning. We will learn the source MAC address. Right. So this is the command to see the MAC table. And coming back to a slide. So wait, I have built a network here just to test you people. Yeah, there is an IP block created with a mask. IP has already been assigned to the devices. Can you tell me the broadcast address of this network? What do you think will be the broadcast IP? Just for testing purpose, right? What do you think is the broadcast? There's a network address broadcast subnetting, huh? You studied that, right? Can you calculate the broadcast address? Are you able to figure out a network has been built? IP, that is the network address. This is the network address, that's the mask being used. 28, what is the value for 28? Tell me. What is the value of /28? Yes? Tell me. /28, how do you write in dotted format? 255 dot? Okay. Pardon? No? No. 255 dot? There are 3 255s, guys. What is the last value? No. No. Huh? No. No. /28 is how many host bits? 4 host bits, 4 network. 4 ones, 4 zeros. 4 ones, 4 zeros is 240, right? 255.240. Pardon? Okay, loud. 442. 442 cannot be a value, right? Maximum we can have only 252, 254. These are the values possible, right? So please recap this because we're going to do a lot of labs, enterprise designs, etc. All this. So know the mask. You shouldn't slow down when you do the lab. Just refer to finding on the mask. So now, the second question would be, what is the broadcast address? Broadcast address. Every network will have a broadcast address. No? Every network that you build will have a broadcast. And this LAN has a broadcast. Try it out. There are calculators also, right? We have online we have sort of apps are there. We can use that. And anyway, not a problem since we don't want to waste time. The broadcast address for this IP will be .159. Now, how do I say that is the key size is 16, correct? So 142.16 is 159. So the broadcast address is 159 for this IP series. So you have to practice this. It should be in your mind. right? Because when I give you lab designs, etc., you'll be working with various masks, not easy masks like 24 and all that. No, you'll be working with such masks. So you should learn how to use these masks. Okay, fine. Now, why did I ask you about this broadcast IPs? Because if I go to any machine, let's say I go to this desktop, right? And I open since you're familiar with the command prompts and all, and I try to ping to that address. I can always ping. Knowing the broadcast address is very good for a network engineer. Why? Because if you know the broadcast IP of your network and you ping to that, everybody will respond to that IP. So it's like an attendance. You'll get to know how many devices are online. That's a very cool thing. So learn how to find the broadcast address of a network. It's very good for networking. So watch. So we have already computed the broadcast address, that is 172.16.140.159. Press and enter. There you go. I'm getting a reply from certain devices. There is a device called 148 in the network. That's a printer. There is a device called 150 also in the network. That's a server. There's a device called 146. That is a L3 switch. There is a device, router is also there, 147. And there is a firewall, 150. And there is one more product missing, 151. Let's see. Let's find out what happened to that. So almost all these products have replied. Can you see that? Except this guy. Let me just log into him and see what happened. Let's see if his IP settings. Okay, he doesn't have an IP, right? Let's just set an IP for him. He was missing an IP. So 172.16.140.151 with a mask of 255.255.255.240. No, 240. Remember, you should calculate very accurately. So that's your mask. Let's try it out again. Let's go to something and find out whether I can ping to all the machines. Is there a response from 151? Yes. Can you see? That's a very cool trick. If you know the broadcaster is a network, ping from your machine laptop, you can find out how many devices respond to it. Now let's go scan the MAC table. Right now I should have 1, 2, 3, 4, 5, 6 devices. 7. Sorry, 3, 4. 1, 2, 3, 4, 5, 6, 7 devices in my MAC table, right? So let's go check it out. Let's go check it out. So show MAC address table actually shows us the 7 devices. Can you see that? Yeah, I think one boy is connected. Dilip. Hello, Dilip. Hello, Dilip. Are you there?
Yes,
hello?
Yes, I'm here.
Yeah, you're here, right? Okay. Fine. All right. So this is a wonderful trick that I've shown you right now. It's a very good practice. And you can see the MAC table being built. All 7 devices, MAC address has been learned by the switch. Now the question is, how did it do this? How did it learn this, etc.? All this we're going to answer right now. But for now, are you okay with the MAC table? And there's a very important thing. Where is the MAC table stored? It's stored in the CAM, content addressable memory. That's why it's got another name. People call it the CAM table because it's stored in the CAM. All right. So let's go back to our presentation. Yeah. So it maintains a MAC table or a CAM table in order to forward traffic. Thanks to this table, the switch is able to forward traffic. MAC table contains the mapping between the MAC interface and VLAN number. You just saw that. Which VLAN, which interface, and what is the MAC of every device. MAC table is automatically flushed. Now, let's wait for some time, right? Typically, it's 300 seconds. That is 5 minutes on a Cisco product. Typically, 5 minutes on a Cisco product. You can adjust the timer. I'll show you the commands. We're going to do some command settings right now. So remember this, by default, it is 300 seconds on a Cisco product. That's called the aging time. Now, why does it do this? Why does it flush? And when does it flush? 2 questions. Why does it flush? When does it flush? If, let's say, 2 people are talking for some time and they've stopped talking. It's idle. That's when it starts flushing. But why does it do that? To save memory. Because CAM is memory. CAM is memory, right? So because this MAC table is stored in the CAM and flushing happens in order to save memory. The next point tells you. In order to save memory, the flushing happens. Now you can disable flushing if you want. Okay, there you can actually set the timer to 0. I'll show you that. If you do the 0, it's like permanent. The table will be permanent. I'll not flush. Now that is actually, if you have too many devices, don't do that. If you have very less devices, you can adjust the timer to 0. Right? So that's one point. So now that you know the L2 switch does all these things, it has another fantastic feature called spanning tree protocol, STP. Now you have studied STP in your CCNA environment. The whole purpose of STP, it was designed by Radia Perlman, a lady, Dr. Radia Perlman. She is the one who designed spanning tree protocol when she was working for DEC, Digital Equipment Corporation. Right? Today she's working for Intel. So this was a fantastic idea by Radia Perlman. She used this idea on a bridge. There was a device called bridge in the past. Okay, there was not a switch. We had hubs and bridges earlier. So she implemented this idea on a bridge, and she proved how loops could be removed in a network using her special algorithm, a special protocol, right? And this became a very big hit that people took this idea and implemented it on a switch. So today, that's why if you open your books and all, every switch has a bridge ID, they say. Have you heard that word? Bridge ID. See, why bridge? Every switch should have a switch ID, right? That's because it was implemented on bridges initially. So This protocol is all about removing loops from the network, completely removing loops from the network. So I've got a couple of questions for you to answer. This is a topology. One second. Let's stop. Right. So there's just, yeah. Can you see this topology, please, guys? Kindly observe this topology. 4 simple switches, L2 switches connected together. You can see certain connections are amber, orange color. You know why it is so. It's been blocked because there is a tendency for loops. It's been blocked. So you all know how it is done. Right? There's a root being elected, root switch being elected, right? And then root ports are found, designated ports are found. There's some criteria happening. So you're already aware of this. So let's answer some questions regarding spanning tree. Okay, let's see if we can do that. Okay. So what is the criteria to elect the root switch in a spanning tree environment? You want to find the root switch. A group of switches connect together, they find the root switch. How do they find?
Lowest priority.
Pardon?
Lowest priority.
Very good. Least priority is a good answer. If priority is same?
MAC address, lowest MAC address.
Least MAC address, okay. The correct answer is good. Correct answer is base MAC. See, switches have something called the base MAC, switches have interface MAC. Every interface of a switch has a MAC. And overall, the switch has something called the base MAC. See. Check this out. When I log into my switch, when I go to command line interface, when I do a command show version, if I type this command, I can see something called the base Ethernet MAC. This is what is used. Can you see that? There's something called the base Ethernet MAC. The entire switch has a MAC called the base. Every port of a switch has a MAC. So if I have a 48 port switch or a 24 port switch, the 24 port switch will have 24 interface MAC and typically one base MAC address. The whole. That's what is very important. We should say least priority, least base MAC address is used for finding the root. Very good. Excellent. Let's see the second question. In a spanning tree environment, you will have root ports, correct? There'll be root ports. How many root ports exist in a full mesh network of 10 switches? Imagine there are 10 switches. Visualize in your mind. 10 switches. Full mesh means what? Everybody connecting to everybody. Everybody connects to everybody. 10 switches, everybody's connected. Full lot of connections. How many root ports will be there? Anybody can answer that. Okay, let me ask you this question. Every switch will have how many root ports? 2? No. Every switch, L2 switch, right? How many root ports will it have? Every switch except the root switch will have 1 root port. Correct? So in this design, in the design that I've given you right at the top, a small design, there are 4 switches here. Oh, 1 will be the root. Do you agree? Root switch has no root ports. Root port is a port on a non-root switch that connects to the root switch. So please, every non-root switch will have 1 root port. So the formula I could say is total switches minus 1. That's the answer. Very simple. How many switches are here? 4. Minus 1, 3. There'll be 3 root ports in this design. So in this question, if you've been asked a question in an interview, can you tell me how many root ports exist in a full mesh network with 10 switches? That's the trick. You'll find 9 root ports only. You will only find 9 root ports because the root switch will be there. He will not have root ports. Everybody will have 1 only. Easy, right? Total switches minus 1. Remember that. Next question. How many designated ports exist in a full mesh network of 5? There are 5 switches. Everybody connected to everybody. How many designated ports exist? If you remember designated port, every connection will have 1 designated port. Every connection between 1 designated port. So the formula for this will be total number of cables. That's it. How many connections you have. So coming to this design, how many connections I have here? 1, 2, 3, 4, 5. There'll be 5 designated ports, 4 root ports in this design. Subtract the number of designated ports from the root ports, you'll get number of block ports. How many root ports are here? How many root ports are here? As I've told you, I told you there are 3 root ports. That is just the concept behind that is total switches minus 1. Got it? Number total switches. You take your total switches. Why that minus 1? Because root switch does not have a root port. Simple, right? Every connection will have a D. Designated. Designated indicates superiority status. Right? On a cable, one of us will be superior, right? Everybody competes. Every 2 switches will be competing. Who's superior? Who's designated? Designated means the superiority. So on a connection, there can only be 1 D. So how many connections do I have here? 1, 2, 3, 5. So there are 5 designated ports because we have total number of, strictly speaking, I would rather say full duplex connections, full duplex, FDX. If it's half duplex, there is another story, but full duplex, because switch to switch is always full duplex by default. Total full duplex links. How many of a full duplex connections that you have? I think they didn't give me the, no problem. You can see, right? Total full duplex connections. How many connections you have? That many designated ports you have. Correct? So in my design here, I actually have 5 designated ports because the root, all the ports will be 100% designated. He's superior. I'm the boss. Nobody can be better than me. So I am designated. So if you log into your switch, your thing, if you log into a switch such as, okay, this guy is the root, right? If you log into a switch like this, let's say show spanning tree, enter, you can see that all ports of a root switch, I'm the root is saying, and all my ports are designated. So this guy's got 2 designated ports. Are you getting? So in this topology, we've got designated here, correct? And this switch, let's look at this switch. Let's look at this switch, command line interface. So he's got show spanning. You can see that he's got one root port. Probably this is the port, one root port, because root port is closer to the root, port number 2. Can you see? One block port, ALT, alternate port, also called the blocking port. This is the blocking port B, or I'll see, because in RSTP we have backup ports. So I'll just put an X here. X indicates blocked, right? And then we have one designated. Are you getting? One designated. So usually the code I train students is RDX. You should learn to mark the RDX code in a switching environment. You need to find the root position and block it. So this guy also has a block port. This guy's got a root port. Root. He should have a root. Even if he doesn't have designated, it's okay. Root port is because you have to reach the root. No. Root port is mandatory. A switch cannot say, I don't want root port. A switch may not have a designated. See, he doesn't have a designated. That's okay. Root port is mandatory. Now coming to this switch. Now this guy has got one root port here. On this connection, see, he's blocked himself. So I'm superior to you. That's why you block. On this connection block. So now you please count how many root ports are there. Total switches -1. How many designated ports are there? Every cable has 1D. Can you see? 1 decimal. How many block ports are there? Subtract those 2 numbers. Can you see? Cool, right? Total root ports minus designated ports. You get. So imagine a rack of switches. If you're really smart, right? If you count the switches, you can tell the root ports. If you count the connections, you'll tell the designated ports. You subtract both, you'll tell how many connections are blocked. A huge design. Are you getting? So these are the tricks to remember. So good. So now, the reason why I'm asking these questions is it's time to read the CCNA. CCNP is heavily based on your CCNA. Heavily. If you can just spend a little bit of your time just revising your spanning tree, we learn all these topics, no? It will really help you and me both. So first question answered, second question answered, third and fourth. 4 questions answered, okay. What is the feature that is to speed up convergence? Anybody can say. That is, when I connect a device to a switch, generally, you see it takes around 30 seconds for the port to open up, right? We have experienced that, right? Any device can now see the switch is sitting idle here. I'm going to connect a PC here. I'm going to connect a PC here. Sorry, yeah. I'm going to connect a PC to the switch. The port will not immediately turn green. It's going to take some time. The port's not turn green immediately. It's going to take 30 seconds time. If you wait for some time, around 30 seconds, it's going through certain states, right? Forward. Yeah, very good. It has to reach the forwarding state. The green light indicates forwarding, but now it's going through listening, learning, etc. Correct? It's saying 30 seconds time, but I want to speed that up. You have learned that. What is that feature? Port fast. Okay, very good. Cisco created a feature. Cisco only created that. It's called port fast feature. If I implement port fast on this switch at this port, the connection will turn green immediately. So that's the answer. What is the feature? Speed up the convergence. The time taken to reach forwarding state. That's convergence. How quick I can go, right? So usually for PCs, telephones, routers, and all, they do port fast. They do a port fast, so that the moment you connect the devices online, right? They can start. If it's a PC, you can start getting an IP address and all that. Otherwise, if the port is delaying, the PC will be stuck with a PIPA address. You might not get an IP address and all that. So this is a feature implemented on Cisco products, wherein you can use port fast at this point to speed up the connection. Okay, that's good. What is the feature that is used to prevent unauthorized access to switch port using Mac? Can you tell me this? I just asked you. What is the feature that is used to prevent unauthorized access? Very good. Excellent. Port security is a technique that you can implement, or a feature that you can implement on your products, L2 switch, to stop somebody from connecting. I don't want him to connect to me. If I know his MAC address, I can, if I want somebody to connect to me, so I will register that particular MAC address. I'll make a list of MAC addresses who I want to allow. That's called the white list. We make a white list. Okay, these are the people I want to allow. People who are not in the list, finish, block them. That's port security. Good answer. Next one. Have you studied rapid spanning tree? See, I don't know what you've studied, what you've not studied. These questions help me understand the level. Okay, so please excuse me if you're not covered. Theory part only, rapid spanning tree. Okay. See, today you must understand the spanning tree that we tend to use today is the rapid version, not the other one. The older one is called the classic, 802.1D. This is rapid 1W. Now, the rapid spanning tree, name itself is a rapid, right? This STP version is classic one, IEEE 802.1D. Here, you'll have this latency of 30 seconds and all, even up to 50 seconds latency is there, right? In certain environments, when you learn about it, right? But here, rapid spanning tree, the latency is, it's about less than a second, just imagine. Worst case, 6 seconds. Worst case delay is 6 seconds. The best case is less than a second, imagine. That means if you connect a group of switches in the RSTP, it will take less than a second to figure out which port is blocked, which port is active. Let me demonstrate that. See this, please. Please look at this demo. I'm going to take 4 switches right now. I'm going to just take 4 switches. 1, 2, 3, 4. Again, 4 switches here. All right. Totally easy. These 4 switches are going to run the old version of STP. We call it classic. Okay. Also known as the code IEEE has given us 802.1D. So imagine this classic spanning tree. Okay. That's IEEE 802.1D. Okay. I'm just putting it here. 802. Sorry. 802.1D. Okay. This is called the classic spanning tree. Very slow. Okay. Then Cisco improvised this. Even IEEE improvised it. They created something called rapid spanning tree, a faster version, RSTP. IEEE standardized it as IEEE 802.1W. That's the code, right? This, correct? So there are 2. Okay. Now in packet tracer, by default, your switches are in classic mode. By default, they're in classic mode. How do I know that? How do I know that? I click on this command line interface. If I just do show spanning tree, enter. Okay, there's no connection. Let's make some connection. You should have at least one connection for spanning tree to work. If you're not connected anything, spanning tree will not be operational. Okay. So show spanning tree, there you go. If you see IEEE written here in the starting, it means you're using classic. The starting, when you do show spanning tree enabled protocol IEEE, you're using the older version. But if you see rapid, it will be written there rapid. That means the later version. So if I want to, so these switches are already in which mode? Classic. So I'm going to go here and program these switches in rapid mode. Just one command can do the job on a Cisco product. Spanning tree mode, rapid PVST. Enter. Just one command. Spanning tree mode, rapid PVST. Have you done this command?
No.
Okay, not a problem. By doing this command, you have just one command. You have made the switch operate in something called the rapid mode. Okay. So now if I do show spanning tree, let's see the proof. Is it true? Okay, then we need a connection, right? If you don't put in any dummy connection, if you put, then only the spanning tree will work. Okay. There you go. Yeah. Can you see that? It's not IEEE. The label changes to RSTP. Right? The label has changed to rapid spanning tree. It's no longer showing you IEEE, the label. Are you getting what I'm saying? So let's see the performance now. We're going to play a small game right now. We're going to play a small game. What we're going to do now is I'm going to program all these switches in rapid mode. I'll just make a copy. In packet tracer, if you make a copy of the switch, you'll get all the configurations, correct? Okay, 1 second. It was the Zoom, right? Yeah. Yeah, see, let's just make a copy of the product 2, 3, 4. Yeah, check this out. So I have these 4 switches. I'll zoom up. Okay. Okay, now let's come down. See this. That's the classic environment. This is the rapid environment. I'm just made a copy. All of them have, you can verify. If I just go to any one switch, just test it. So show spanning tree, enter. Okay, we don't have a connection. We'll make a connection. Yeah. Click. So it's in RSTP. So copying worked. Okay. So now what we're going to do now is I want you to see the beauty of RSTP right now compared to this. So let's see who's fast. Okay. So we're going to start with this guy. We're going to start making connections here. Then I'll jump here. See the convergence time it takes. Watch. I'm going to make a connection here. See classic and just make a square out of it. See, he's still thinking which port to open, which port to close. See, I've not yet connected RSTP. Watch the performance. See, the moment I just connect, you see, finished. Over. Can you see? It has already determined that it has to make a port as a connection block. It has already determined. Can you see? That guy is still running. Can you see? He's still running. He's still not figured out. Right? The more efficient variant has come out called rapid spanning tree. So the question that has been asked here is, how is rapid spanning tree able to do this? How did this guy do this, which he couldn't do? Anybody? What makes rapid spanning tree rapid? What gave him that speed, the performance speed? What made RSTP rapid? You have done the theory, not the practical. Actually, practical is easy. Just one. Pardon? No. Nothing. Nothing like same config. Whether you do same con, different con, rapid is rapid. I'm fast. What makes me fast? That's the question. Anybody know theory? Okay. There is a process called proposal agreement. Rapid spanning tree implements a technique called proposal agreement. It's like how a boy and a girl meet. A boy proposes and a girl may agree, may not agree. Right? Yeah. Same thing in RSTP environment. what is happening is the moment you connect a switch, the moment you connect so fast within fraction of a second, one of them will send a proposal. The other one may agree or may not agree. So what is he proposing? What is the switch proposing? He's proposing, I want to be the designated port. Every connection has a D, no? Proposal is just a BPDU, right? It's just a BPDU, right? There's only one BPDU called RST BPDU. It's just a flag inside a BPDU. So what this proposal does is, I want to be designated. That's what he's asking the other guy. Now, this guy might, now, you know how designated port is found. They check each other's what? What is the first thing they check? To find the designated, who is designated? What do they check? Tell me. I want to be BP. I want to be designated port. So this is just a recap session, okay? Right? This is just a recap session to get, so that you get to know me and I get to know you. Very simple. Because you have to revise and come. That's very simple. Right? This is not yet the switching element. So a proposal has been sent saying that I want to be the designated port. Now, they will compare criteria, right? They will compare criteria. They will check their priority max, just like how the election, and they will, whoever is having the lower values will become the designated. So if the right side switch, if he is lower, he will send a counter proposal. I will propose back. Okay, I will send a proposal if I am lower, but if I'm higher, I will agree. Agreement is like, yeah, man, you be designated. But if I don't agree, I will send back a counter proposal to you. This PA, it's called a PA process, is so fast. The moment you connect cable, they'll figure out who's, it's electricity, right? Everything is the speed of electricity, right? I just send message to him. So every time you connect the cable, designated port is found. If the designated port is found, the other state is automatically determined, right? The root port of it. That's the secret behind RSTP's PA process, which will be highlighted as we go forward. So the PA process is a very, very important part of the RSTP. Okay, so look at this. So what is required by the, I'm sorry, we are in the other section. Yeah, this question. Yeah. Look at this. What is the feature that is used to speed up that you answered, or what flags are used in RSTP? That's the question, right? This is the question we are right now. And which flags are used in rapid spanning tree for fast conversion, etc.? So the answer is proposal agreement flag, PA. So flags are just values, okay? Booleans, 0 or 1, the values, PA flags. So don't worry, this is just to tell you, such things are being part of rapid spanning tree. Classic is gone. People are moving, that's already gone long back. It's all rapid. Spanning tree itself is dying away. Okay, in the modern environments, etc., spanning tree is being replaced now. Right? Everybody is preferring routed access designs, layer 3 designs, right? If you ever studied spine leaf architecture and all that, no, you'll see spanning tree is not there at data center. Many places, spanning tree is also being removed. Because the problem with spanning tree, it blocks certain connections. So what happens is connections will become underutilized. Certain cables are blocked. Spanning tree has to do that to prevent loops. But from the perspective of the network admin, he's like, some connections are wasted, no? That is why STP is actually being removed from networking itself. But in your syllabus, it's still there, right? So what is the purpose and drawback of using TCN BPD? Anybody? Have you heard of the word TCN BPD? Anybody? Have you heard of the word TCN BPD? Anyone? Yes? Anybody? Have you heard of the word TCN BPD? 1 second. I think one more. Yes, Dilip. I'm sorry, since you're online, I couldn't. Yeah, Dilip. Question is for you also, okay? For everybody.
I'm sorry?
The question is for you. You're able to see, right? What is the purpose?
Yes, I'm able to see.
Any idea on TCN BPD?
Not really. No.
No. Okay. Not a problem, guys. See, TCN BPD stands for Topology Change Notification Bridge Protocol Data Unit. TCN. What is this BPD is all about? It has been created. It was used in Classic actually. This BPD was used in Classic spanning tree, not in the Rapid. In Rapid, they don't have this. In the latest version of Rapid spanning tree, they don't have this. So what this TCN BPD does is, I'll just give you an idea. But these are just highlights of what you should know before doing the CCNP. And you got no. These questions have to be known before getting into CCNP. Just a review on your syllabus. Right? So what is the TCN BPD use? Let us say you have a PC connecting to a switch, right? PC connecting to a switch. This PC, maybe it has shut down or the connection has failed or something happened to the PC. Now, in our design, this is the root, right? This is our root. Anybody could be the root according to the criteria, right? In this case, this is the root. In our design, that's the root. Something happened to the PC's connection or the PC has shut down, whatever. So that's a failure, no? Connection failure, no? Spanning tree will report that. To whom? The boss. The root doesn't know this. The only switch that knows this is the directly connected switch. Only this switch is aware of the failure of the PC. So he takes the responsibility to notify. TCN stands for topology change. That is the change in the topology, right? Even if you add a new connection, says it adding or removing, it's called a change. The action taken by the switch is it will send out something called the TCNBPDU, topology change notification, out of his root port only. See, he's got a block port. He will only send it out of root port, not out of designated, not out of alternate or blocked. So a special BPDU will be sent out. It's a very small information, very small information. This is just about 4 bytes. That's it. This BPDU is about 4 bytes. It's very small information. It sends out the TCN BPDU. Upon receiving, the switch will send out of his root port. The goal is this message has to be given to the root. Topology change notification to tell the root, hey boss, something happened in the network. But the message does not tell what happened. It just tells something happened somewhere. It's a very small message. It doesn't contain the MAC address or the PC, nothing. It's just one alert, like a notification. It just, hey, something happened somewhere in the network. The root is like, oh, okay. Something happened in my spanning tree domain. Right? What the root is going to do, he is going to send back. The moment he gets the TCN BPDU, the root is going to send back a message out of all his designated ports. I repeat, TCN BPDU is sent only out of root ports. Only out of root ports TCN, just to notify the root, because root port takes you to the root, right? That's why it's called root port. So send the message through the root port, it will reach the boss. Upon getting the message, the boss will react. He's going to send out a CBPDU, configuration BPDU. CBPDU, we call it the next type of BPDU, CBPDU. Input is TCN, out comes the CBPDU. And inside this BPDU, inside the CBPDU, he's going to set one value called TC. It's also called a flag, TC equal to 1, topology change equal to 1, because other switches may not know it. See, does this switch know about it? Does this switch know about it? No, right? There may be other switches in the network, right? Only certain switches are aware of it. So boss now takes the responsibility to inform whom? Everybody in the TCN BPDU goes to everybody in the network. Sorry, CBPDU, I'm sorry. TCN BPDU only reaches the root. Boss, something happened somewhere. Boss, what you'll do? Generate a TCN BPDU, send it out to everybody. You know what everybody will do? They will flush their MAC table. Because this PC's MAC address may be available. They would have stored the entry, right? The PC is dead or offline. What is the point of storing the MAC address? Correct? So this is how it works, this classic spanning tree. If a moment a PC is disconnected, or any device, router is disconnected, printer is disconnected, any sort of device that is disconnected. Let's say the first topology that I've demonstrated here. See, let us say you had a firewall. The firewall got disconnected. Immediately, this guy will report to the root. If there is he'll inform the root, if the TCN, hey boss, something happened. Immediately, the boss is going to do what? Send back a CBPD to everybody. Hey, all of you guys, everybody, the whole campus. That's actually bad. That's a bad drawback. That is the reason in RSTP, this feature is not there. This is old idea, guys. Classic spanning tree, this concept was there, right? That's very old idea. So those days, people, networking was not so extensive like today, right? People today are very much smarter and much more concerned about the traffic in the network, etc. But those days, the moment a device fails, report to the root switch, and root switch will tell everybody to flush your table. The reason why he told everybody to flush is because the firewall is offline. The firewall's MAC address would have been stored everywhere, correct? Why you people are storing? Save your memory. That was the intention. You got what I'm saying? But flushing the MAC table has a side effect. Because a switch without a MAC table behaves like a hub. It will start broadcasting. Because initially the switch has no entries. What will it do? Will it drop or it will flood? Broadcast. Or flooding. Correct? It will flood out the traffic, right? It will flood out. That's one. So the question was, what is the purpose of TCN-BPD? I answered the question. Purpose of TCN-BPD is to notify the root switch about some connection link failures, any link failure, anybody failed, any connection failed in the spanning tree domain, notify the boss about it. That's the purpose. That was the question. I answered that. That's the purpose of it. Now the next point is, see here. Where is that? Yeah, what is the purpose? And drawback. What's the drawback? It's going to flush the MAC table. Flush the MAC table. Everybody's going to flush just for one PC. One PC switched off. You're going to flush every single MAC entries from the table, right? Every single MAC entry is going to flush, because flushing those days on a device cannot be on a particular MAC. Are you getting those? So this feature was pretty bad. This TCN-BPD technique. That's why it's not even there in RSTP. In rapid spanning tree, they don't even introduce TCN-BPD. Just because in a company, users will log out, log in, people will come and go. Imagine morning shift, night shift, etc. As anybody joins in or anybody logs out, flush. Every time logging out, flush. That's a very bad practice. That's a drawback, okay? Why does STP priority increment by 4,000 IDs? You have set STP priority, right? You know that you can't give any number you like. You can't just give a number like 1, 2, 3, 4, 5. You can't. Let's log into a switch. Now see, I want to make this switch as the root, this switch as the root, any switch. I want to make him as the root. You know the command to make a switch as the root. You log in and then spanning tree, choose your VLAN, whatever, and priority. Now I try to put a value 7, it'll give an error. See, it says sorry. Can you see that? It's not letting me use a value. It's saying use increments of 4090. You can only use these particular values. Yeah, when you have learned how to set, make a particular switch as root switch, right? In your CCNP, yes. You have a group of switches, you can program a particular switch as the root by setting its priority. But the surprising thing about this priority parameter is that it is not continuous, right? There is a jump, there's an increment. It's like plus 4096, plus 4, it jumps in 4096. 4096. So if you use your calculator, you will always see that the priority, if it is initial value 4096 plus 4096, it is always going to increment in multiples. See? Next value is 8192, right? Again, I press equal to 12228. Can you see? Next value 16384, 24080, 24573, 286 and 3. See, priority is incrementing like this, right? You can't just give any value you like. 32768 is the default priority. You know that, right? That's the default. But the question here is why? Why is this priority incrementing? Why does the STP priority increment by 4096? Why is it happening? Why is it not continuous? Anybody? No? See, the priority has how many bits, you tell me? Priority is a number. IP address is a number. V4 is 32 bits. V6 is 128 bits. Priority is also a number. How many bits? Anybody? STP priority. How many bits? If you know how many bits, you can answer this question actually. 16 bits. Okay, I give you, that's a good answer. But you see, that is called total priority. Okay, there is something called total priority. Okay. The total priority, what you're telling is 16 bits. Okay, this total priority concept is broken down into two things. Just priority and something called system ID extension. Has anybody heard about this? System ID extension. Yes, no. System ID extension. Has anybody heard about this? You're right. The total priority, I use the word total priority 16 bits. But the priority is again broken into two components, two parts. Priority, and this priority is only 4 bits. And the system ID is 12 bits. Okay, this is today's concept. See, once upon a time, in the oldest version of spanning tree, much older than this, priority was, you can give any value you like, any value you like. Later, as time passed, they introduced system ID. Anybody can tell me this. It's amazing if you can tell me the answer to this. System ID extension. What is system ID extension? Anybody? You have seen this actually. See, if you go to the show spanning tree output, if I just type show spanning tree output, you would see that actually. Maybe you'll get a clue to what that is. See, if I do show spanning tree, enter. Can you see that? I can see something called the system ID extension here. And I can see the can you see in bracket, this together is total priority. This number plus this number will give you total priority. Can you see? Can you see that? Can you see that? So what is system ID extension? Anybody? Can you give it a try? Anybody? What is system ID extension? Give it a try. Yes, Dilip. Can you give it a try? Yes, anybody know? No? No guess? It's nothing but the VLAN number. It's nothing but the VLAN. Let me show it. Let me prove it to you. Watch. The system ID extension is nothing but the VLAN number. When the VLAN technology was created, they removed some bits from the priority to accommodate VLAN value. VLAN is 12-bit number. A VLAN is a 12-bit number. How many VLANs are there? 0 to 4095. 2 by 12 is 4096 VLANs. 0 to 4. 12-bit number. So you see, so that the switch can record even the VLAN number. So there some amount of priority bits got lost. Okay, and now priority has only 4 bits. So priority can only have 4 values. Remaining bits were occupied by VLAN. So look at this, please. So if I create a VLAN here, let's say I create a VLAN here, VLAN 10 to prove it to you. And I just make a trunk, something like this. Okay, just ignore all that. I'll just go show spanning tree. If you observe, I create a VLAN 10. The system ID extension now has become 10. Can you see that? Can you see 10, 10? Can you see? The system ID extension value is the VLAN number, which is combined with the priority to create something called total priority, which is used in the election. Are you getting what I'm saying? So the priority is only 4 bits now, not 16 bits. So 4 bits, how many possible values you can have mathematically? Do the permutation problem, 2 power 4. Bits, no? 2 power, how many values are there? 16 values. So look at this. You can only have, what is this? See this? How many values did you count here? How many values do you count here? 16. The priority is a 4-bit number, which can only give us 16 numbers, possible numbers. 16, but you combine it with VLAN number 0000, initial value 0. 000. Next value of priority is what? 0001. Again, VLAN 1000 is 4096. If you use a calculator 0001 and then 004,009, next value of priority is what? 0011, like that. So that's why you get the jump. Are you getting what I'm trying to tell you? Right? So this is a highlight on the span tree. So it's very important to know STP if you want to survive in the CCNP. Right? So what are the various STP states? Can you tell me? STP in STP environment, we study states and roles. Roles are root port, designated port, alternate port. If you're using RSTP, we have one more called backup. Backup. RSTP, rapid mode. Backup is there. 4 rows are. I'm talking about 802.1D. 1D means classical. How to remember this D? I used to always, as a student, old, no? OLD. The 01D, no? Old. Right? We should have techniques to remember, right? Let's remember 802.1D because the exams, if you ever take a season, they will never write classic. They'll write this IEEE 802.1D, 1W. Right? So that you'll be forced to rethink. Hey, what am I doing? What should I? How do I answer the question? Because the way you answer the D question and the RSTP question are different, even though both of them are having the same purpose. What is the purpose? Loop avoidance. So, what are the states associated with 802.1D? States. Pardon? Very good. Listening, excellent. Listening, learning, forwarding, disabled, and then block. Blocking, listening, learning, forwarding. That's the order, okay? First, the moment you connect, it starts with blocking, jumps to listening, then learning, spends certain 15 seconds, forward delay, then learning, learn the MAC, then forwarding. Disabled is a state, but it's not part of this. When a port gets into error disabled state, or when there's some security violations, no? That's when the port gets into disabled, or you shut down the port, it's in disabled. 5 states are there. 5. Answer to this is 5. Disable, blocking, listening, learning, forwarding. Out of this, in the learning state, the switch will learn the MAC. The MAC table will be updated in the learning state. In the learning state, right? Are you getting what I'm saying? It is in the listening state, the switch will figure out what? Designated status. Yeah, all those kind of thing, criteria, checking all that. That's the listening, checking part period. 15 seconds are invested in listening state. In learning state, another 15 seconds is invested to learn. But that's bad. 15 plus 15, 30. That's why port pass has been implemented, right? Cisco created port pass. Why you want to invest 15? And RSTP also has come up. In RSTP, there is no learning is super fast. To learn on Mac, why should I spend 15 seconds? Are you getting what I'm saying? Today, all these concepts are dead. So, but you should have an awareness. So make sure you know the STP. Good, you have sufficient knowledge, but enhance it. Okay. Make sure you learn how to work with this planetary environment. Okay, great. So let's go back to our PPT again. We are back here. So spanning tree variants. Next, it implements VLAN technology to perform network segmentation. VLANs, virtual local area network. That's one of the most interesting, most favorite love topics, right? Scoring topic also, VLAN, right? We've done labs, right? VLAN, inter-VLAN, trunking, access link, tagging, all those things, right? So let's see if you're able to handle this question. So now let's take another topology, right? This topology. So we have a switch, L2 switch. Again, L2 switch is used for all this spanning tree, VLAN, implementation. We have an L2 switch wherein there are 4 PCs. You have segmented. Segmented means what? Separated them. VLAN is all about segmenting, dividing. Right? So VLAN 10, VLAN 20, we have 2 different IP blocks. Yes. Tell me, answer these questions. What are the reasons for doing the segmentation? Why do we do segmentation using VLAN? Pardon? Channelize means? Pardon?
Efficient way of traveling, the flow will be efficient.
Efficient flow of traffic. If I did not have VLAN, there's still efficiency is on the switch, right? S6. VLAN doesn't increase the performance. No, VLANs never increase the speed of the switch. On that is S6. The chip is there. Pardon?
Segmenting will be there.
Yeah, that is the question. For network segmentation, we're using, but why are we segmenting? Why do we? You're right. We are segmenting the network. We are breaking it down into many parts. Yes, very good. Huh? Control. What control? What control? What control? Control the broadcast traffic. That's a very good answer. Broadcast control. This is one of the cool features of implementing VLANs on an L2 switch. Traditionally, only routers could do this. Only a router was known as a broadcast controller, right? If you send a broadcast to the router, what the router is going to do? Stop. I'll not forward it up. So L2s couldn't do that earlier. Now an L2 switch has this VLAN implementation wherein if this machine sends a broadcast, right, it will not be received by other environments. That's one of the major reasons broadcast control. Other reasons? One of the reasons is broadcast control. Yes? What's the second vital reason? Second vital reason. Security. Security, right? Security is one thing. Members of a VLAN by default cannot talk to members of another. There is a wall, security wall between us. right? You cannot until you use some L3 device like router or a firewall or L3 switch, etc. Some L3 product, then only you can. But otherwise, the members of one VLAN cannot talk to another VLAN. They can't. There's a security benefit with VLAN. There is broadcast control benefit with VLAN. Flexibility. Members of a VLAN, you don't have to sit on the same physical switch. Now I have one VLAN member here. Some other person can sit on another switch itself. Physically, you can be not on the same switch. You can be spread out. You're not supposed. It's not compulsory that these two guys have to be on the same physical location. You can spread out in your campus, right? Flexibility is another cool reason. Another thing is you save money. Cost-effective hardware. How do you save money? See, basically, what does a VLAN do? You are partitioning your switch into virtual switches. You're breaking down your switch. You break down your physical switch into what? Virtual switches. That's why it's called a virtual LAN, VLAN. You're in fact, you're creating a virtual environment. You're creating a virtual switch internally. Inside the switch, a virtual switches are created. So this design will look like this actually. This design will look like this. Are you getting what I'm saying? So a virtual switch is implemented inside using this technology. And these two switches are not connected to each other. That's why there's a wall. There is no connection between them. So members of one VLAN cannot talk to the members of another VLAN. That's security, flexibility, and then you save money because see, now I have two switches. I can create more and more and more. Instead of buying a physical switch, I can work with virtual. I can reduce my hardware count. No, see, I need hardware. It's not that you can completely eliminate hardware. Then everything will be ghost. You can minimize the hardware usage, right? You can minimize the usage of hardware. Right? So that's another reason of using VLANs in our organization. You save money. Instead of buying 50 switches, I can buy 10 switches, implement 5 VLANs in each, 10 into 550. Cool, right? So VLANs are fantastic that way. Great. Those are the vital reasons of using VLAN. What is the feature that can be used to restrict traffic inside a VLAN? I already told that. You have created a VLAN. You got people inside. Huh?
Segmenting.
No, VLAN is already inside the VLAN. How to do? I have created a VLAN. All members can talk to each other. Now all of you are in a VLAN. What does that mean? Each of you can talk to each other. I want to stop. I don't want you to talk. I don't. Huh? Pardon?
No, switch then.
Authentication means you're not getting what I'm trying to say. All of you are in a single VLAN. You're all part of a single VLAN. That means what is the rule? All of you can talk to each other. All of you are authenticated. You have you're in the same VLAN. Same VLAN means what? Equal rights, correct? But I want to stop some of you from talking to each other. Some feature can be implemented. Yes. What feature can be implemented within the VLAN? Yes, Dilip, you're there? All questions go to you also. Hello?
Yes.
Yes. Can you kindly help us out? What is the feature? Yeah, tell me please. No. No? Okay, not a problem. See, there are two interesting features. One is called VACL. VLAN access control list. You can create something called a VLAN access control list. Just like a router ACL, we have VACL. You can create and you can control traffic inside the VLAN. I repeat, router ACL controls traffic between VLANs, RACL. VLAN to VLAN, I want to only allow certain, that's RACL. VACL, or we want to learn private VLANs. That's a fantastic concept. In your CCNP switching, we have something called private VLAN where we can create community isolated VLANs, etc., wherein you can restrict access. See, when I joined here, I was seeing a live implementation of private VLAN in the lab itself. They have done it in the NH, right? In the NH, they have already set a private VLAN environment. So that's that important. You see, it's private VLAN. It actually implements security within a VLAN. Private VLAN or VACL. These are the two techniques. See, I'm just discussing. I'm not showing any practical as of now because this is just a formal understanding between you and me. Okay. What are frame tagging? Okay, wait. Where is that? Next one. This one. So we finished this. We finished this. L3 switch. Okay. Difference between an access and a trunk link. Third one. What is the difference between access and anybody can tell me? What is access? What is trunk? First, you tell me what is access, trunk. Quickly, Arya. What is access? What is trunk? You have learned this in VLAN. You should never forget that. What is access? What is trunk? Yes, Dilip.
Access port, VLAN traffic is accepted. Only same VLAN traffic is accepted in access port.
Single VLAN traffic it carries. Excellent.
Yeah.
What
trunk port, multiple VLAN traffics are accepted.
Okay, beautiful. An access link is a connection that carries only single VLAN. A for alphabet A, first letter, single VLAN. Trunk link carries multiple. Never forget that. Trunking is all about carrying multiple VLAN traffic on your connection. Good. So can you tell me the difference then? This is one difference, correct, between access and a trunk. Any other difference? Access link carries single VLAN, trunk all. Okay. That's the definition part. Any other difference? In terms of bandwidth, where do you think bandwidth is efficiently used? Trunk or where do you think that there is more bandwidth on an access or trunk? Imagine you have an access and a trunk link. Where do you get more bandwidth? Think again, access. Because single VLAN, no, it'll enjoy the full bandwidth. Everything for me. Trunk is what you're sharing. You'll not get the full bandwidth. So another difference access and trunk is an access link, you get full bandwidth. A VLAN 10 access link, you create a VLAN 10, complete VLAN 10 traffic and enjoy that bandwidth. Maybe 100, maybe a 10 gigabit link you've created for VLAN 10, full 10 gigabit. But you created you created a trunk link for 3 VLANs, 10, 20, 30. What they're going to do? They're going to break down the 10 gigabit sharing, right? So bandwidth, if you talk about bandwidth wise, no, access link enjoys much more bandwidth than a trunk link. Full bandwidth use, right? Another difference between an access and a trunk is in terms of security. Which link is more secure? Access or trunk? Access, very good. Because trunk is mixed, right? So imagine there could be a hacker also in part of the traffic. No, hacker's traffic could be there. There is a chance of the hacker hopping. There is something called VLAN hopping attacks. A hacker can jump from one VLAN to another VLAN. Just imagine. There are a lot of techniques, a lot of tools. One of the tools they have something called Yersinia, or you might have heard of Kali Linux, etc. All these tools. There are a lot of built-in the Kali Linux OS. There are built-in tools into that which can perform VLAN hopping attack. Allows a hacker to jump from one VLAN to another VLAN without the help of L3. Usually the rule is what? You need L3 device to jump from one VLAN to another VLAN. That's the rule, right? But VLAN hopping is an attack that will not require an L3 device, right? Techniques like double tagging, right? Techniques like double tagging, or techniques like using the native VLAN and all can create. That is a secret risk. Next question. Okay. So that is one reason. So when you talk about an access link, it's secure, much more secure than a trunk. When you talk about access link, it gives you much more bandwidth than a trunk. But the greatest benefit of trunk is what? Less cables. Less cables. No, one connection you carry all. Access, if I have 10 VLANs, 10 connections you have to pull from the switch, right? I create 10 VLANs. I want to use access concept, link concept. 10 VLANs are to pull from the switch. Correct. With trunk, one. So less wastage of ports trunk. So you should have a clear-cut difference between access and it. Access is good in many ways, but drawback of access is too many connections. Trunk is excellent when you want to save connections. So what do you think is being used in an environment? Access or trunk? Mix. It's a hybrid. They will plan. Everything is planned. Which part should be trunk? Which part should be access? Everything is planned. But it's not that, oh, let's use access, let's not use trunk. Mix of both. It's well planned. Where you want a good bandwidth and all, put access. Where you want to share, put trunk, etc. All these kind of things. Okay. What is the anybody has an idea with, okay, what is required by L3 switch to perform inter-VLAN? Next question. What is required by L3 switch to perform inter-VLAN? I want to do inter-VLAN communication. Typically, we use routers. But now people are not using routers. They're using L3 switches. Why? Because remember the S6 chips are there? L3 switches are faster than routers. So they're removing off routers. Routers are pushed to the edge of the company now. Traditionally, routers were part of the distribution layer, right? Distribution and core. Now routers are going out to the edge. Pushed out. No more inside the organization right now, the routers. We'll talk about the architecture in your study. But for now, I want the answer to this question. If you had a layer 3 switch, let us say this, I'll show you if you want to know. See, this is an L2 switch, right? Can it do inter-VLAN communication? No. L2 cannot. L2 cannot move traffic from one VLAN to another VLAN. L2 can create VLANs for us. He can do segmentation for us, but he cannot move traffic from one VLAN to, he can do VACL for us. All those things he can do. If I want to do inter-VLAN communication, I can use routers, L3 switches, firewalls, etc. L3 switches are better because it's faster. They have designed it to be faster. So you see, I'm going to put an L3 switch. The question to you here is, I want to do, watch now. I would like to, let's just do one small, let me see. Yeah, 365. I've got an L3. As of now, this machine wants to talk to this machine. It cannot fail. There is no communication. But within this machine wants to talk to this machine, success. Can you see? There is proper communication as of now inside the VLAN. Obviously, you're in the same network. So that means what? We can talk to each other. Correct? Same network, we can talk to each other. No problem. Same yellow can talk to each other. That is the story of segmentation, right? Yellow can talk to each other. Pink can talk to them. But pink and yellow cannot talk unless and until there is some sort of. See, now the pink wants to talk to yellow. He's not able to. See? He will not. He will not be able to send the traffic. Okay. Yeah, see it. 1 second. Packet tracer. Yeah. Pink wants to talk to yellow. See, it's unable to talk itself. Usually you get an X mark there. The bucket is a small memory buffer. So you can see that. Okay, I'll just clear that. It's not able to do communication. I'll just come out of simulation real time. You can see the failure log here. Can you see? In program, no matter how much I try, I'm not able to move the traffic. L2 is not designed for that. So you need to put a L3 switch. So let's plug in the L3 switch now. I'm going to connect an L3 switch into the environment. Now the L3 switch is like a gateway. Gateway between two VLANs. It will allow two VLANs to talk. Now you can go and implement RACL and all those things here to control. I don't want this guy to talk to that guy, etc. You can, but by default, he will allow anybody to talk. What should I do to program the L3 switch? That is a question asked. I'm connecting an L3 switch which is faster than a router. If you're using router, we will do what? Sub interfaces. Yes or no? You've created sub interfaces. Have you done router on a stick? One-arm router labs? Yes. You create a sub interface, right? You build sub interface and work. But this is not the question on router. You are using an L3 switch. You're connecting an L3 switch to a normal L2 switch. What should I do to make these two VLANs communicate? Yes. Anybody? Yes, Dilip? Yes. Anybody? You got my question, right? Something has to be done on an L3 switch to enable communication between these two VLAN members. No? We need to, yes, no? We need to create something called an SVI. All this we'll be doing in the lab. SVI, Switch Virtual Interface. INT VLAN, have you done that? INT VLAN number, giving an IP address, no shut, no? Yes. Yes, that's called the SVI. You need to build something called this L3 switch should have a virtual interface. And that virtual interface should have an IP address. Two SVIs you have to create, okay? One SVI will take the IP address from this block, another IP address from this block. So this is like two logical interface. You cannot see this. Inside the L3 switch, you have to create two logical interfaces. It's called a switch, S for switch. Switch virtual interface. Two interfaces you need to create and it will allow them to talk. Let's do that. See this. So to create an SVI is pretty simple. All you have to do is, see now I'm going to my L3 switch. Let's power it up. Put the power connections. Yes. So the L3 switch is booting up. So since it's booting up, let's just write the notepad, the commands. What can I do for this interval? As of now, you saw these two guys are not, the VLANs are not talking, right? So we're going to go create something called the switch virtual interface. So I'll do this command called INT VLAN followed by the number. Which VLAN are we talking about here? 10 and 20. See, VLAN 10 is the VLAN 20 there. See, we are not here. We are creating an interface into the VLAN. That's why it's called switch virtual interface. And we give an IP address. You should give an IP address which is not being used in the network. So I'll try to give it as one. The first IP is usually given 10.1 and the mask. Got it? No shut. We build one SVI, another SVI. Number of SVIs you build will be equivalent to the number of VLANs. Always remember that. So this is very critical point. So I'm going to build one more virtual. These are all virtual interfaces, which you're giving an IP address. So this is in this block is 20.1. Can you see two blocks? Choosing one IP. Now, these SVIs cannot work unless and until you create the VLAN. Loopback is also virtual interface. SVI is also virtual interface. When you talk about virtual, both are same. But in terms of functions, both are different. Loopback is mainly for testing related purposes, management purpose, etc. SVI is mainly for inter-VLAN communication on L3. Okay, see, loopback, tunnel interface, SVI, all these are logical interfaces. I think they're all logical, but each of them will have a different function to perform. So we basically built an SVI for inter-VLAN communication on a L3 product. So now see, but you see, I'm going to take this, copy it and paste. It will not work. It's not going to just work. This is required, correct? See, I'm going to log in. I'm going to log in and this is my switch. Let's say, let's call it as SW something. Okay. I'm going to just paste it. Everything is accepted correctly, right? So I've just pasted my configurations here. VLAN 10, VLAN 20, right? So now the switch is having two IP addresses, correct? I can check that out by doing a show IP interface brief, but there is something interesting to observe in that. Show IP interface brief. Check this out. If I scroll down, the switch has created, along with the physical interface, there is a logical interface shown. Can you see that? By default, there is an SVI called VLAN 1, already built into the switch. You can't remove that. You didn't create it, so you can't remove it. But we have customized and created our own, and there's an IP. But did you observe it's down? The interface is not operational because the VLAN doesn't exist. You're not created the VLAN, right? You just went and created the VLAN interface. So you must, whenever you create an SVI, it is mandatory to create what? The VLAN. Then only this will get life. The interfaces are down. They have no life. Still the PCs can't talk. See? If the PC wants to talk to this PC, they cannot. They're still showing failure status, even though SVI is here. Right? It should be active. The SVI must be active. And the L3 switch will update this in the routing table. But right now, routing table is empty. Can you see this? In fact, routing table is disabled. Can you see? So there are a lot of things to do on an L3 product. Okay, and an L3 product. When you work with an L3 product, you can see that this is not the routing table. Right? Show IP route is the command to see the routing table. Everybody agrees? But is this the routing table? What does the routing table generally show? It shows certain codes, etc. This is not the routing. The routing table is disabled. So on L3 product, you have to do IP routing to enable the routing capability. You start with that command to activate the routing capability. Otherwise, it will not move traffic. This is behaving like L2. Even if you buy an L3 switch, it will by default behave like a L2. And I have seen certain models that by default behaves like L3 also. That model dependent it is. Right. Anyway, but in this packet tracer model, you can see that this 3000 series model is not enabled with routing capability. Now, the moment I type the first command, the routing table will be active. See, watch. IP routing. Okay, let's go see show IP route. Wow, that's your routing table, right? The codes and all that. Can you see? So we have configured enabled routing. We have configured the SVIs, yeah, the two SVIs. Now, still not much of a luck. The SVIs are still down. The SVIs are still down. And you see the SVIs are still down because we have to create the VLAN. We need to build the VLAN. Without the VLAN, don't even expect. So VLAN 10, VLAN 20. That's it. Right? The moment you create the VLANs, let's just go put that into this. So paste it, then there you go. You can see the log messages coming. Some syslog messages are appearing, right? And a notice, usually 5 is a notice showing that SVI 10 and 20 are up. If you check your interface table, you can see they're up. And as of now, it's still showing down. One more vital reason. See, now this part came up. Can you see? See, working with SVIs is very important. First, make sure you have the VLAN created, right? You build the SPI, make sure routing is enabled, all these things, but still it's showing down, up, down this time, right? It's still showing up, down. The SPI is still down. The reason because this connection is an access link by default. By default, a connection between two switches. I take two switches and I just plug the wire between them. On which VLAN it will be? One, default, right? But we are talking about VLAN 10 and 20, no? So this connection is not ready to carry VLAN 10 and 20. You have to convert it into a trunk. Only if you make this connection into a trunk, will it carry the 10 and 20. Look, that's what you told me. Starting, I asked you the most important question. What is the difference between access and trunk? Access carries single VLAN, trunk carries multiple. The connection from the L3 switch to the L2 switch must be a trunk. Otherwise, you cannot do inter-VLAN. Are you getting? So when I go back to my notepad, I have to make sure this port. So let's just go and check my port out. Options, preferences. Always show port labels. Okay, what is the port label there? G1 bar 0 bar 1. That port must be configured as, let me just, as a trunk port. G1 bar 0 bar 1. See, by default, your ports are all access. I can prove that to you. You log into your switch, show VLAN brief. How do you know is it an access? Show VLAN brief. Sorry. Okay, show VLAN brief. Okay. So if you look at this, can you see VLAN 1 default VLAN? VLAN 1 is designated as default, and there's port number 1. Almost every port of this switch is marked as marked in VLAN 1. Can you see? So and think about it. You want to do inter-VLAN. Inter-VLAN means what? The traffic from this PC must take a hairpin bend. This is called a hairpin or backhauling, we call it. Yeah, we call it the hairpin. Have you seen the hairpin? It's like that. We call it the hairpin bend or the backhauling. Right? This strategy also people call it as the one arm. In routers, it's unarmed router on a stick, etc. Right? You have studied that. But you see, the traffic must go like this and come. So this connection must carry 10 and 20. Common sense, right? So it has to be what? Trunk. That is a very, very important requirement when you work with inter-VLAN using L2. So this compulsory, never forget this. So let's program the trunk. Let's program the trunk. So I'm logging into this. So you all know how to build the trunk. Yes? Can you help me? I've interface G1 bar 0 bar 1. What? Yes, Dilip, you're also there. Eh? What can I do? I want to make that port into a trunk port. Yes? Commands? No? Switch port mode. Very good. Access is access. Eh? Mode trunk. Very good. A simple way of building a trunk. It's called the on mode, the manual mode of trunking. Later we'll see DTP and all. But switch port mode trunk is more than enough to build a manual trunk. Switch port mode trunk. Right? Apart from this, we have additional commands like specifying the tagging and all that. But that's the next question that I have to ask you. So before I type that command, you have to finish that question. What are the frame tagging protocols used on a trunk? Can you answer that? On a trunk, tagging is done, everybody agrees, right? Because a lot of traffic is existing on the trunk, carries multiple VLAN traffic. So every traffic is going to be tagged with the VLAN number, right? There are protocols that are going to do the tagging. When a switch is sending traffic to another switch to switch, there's a connection, right? Somebody has to do the tagging protocols. What are those protocols? Yes. What protocol can be used to automatically negotiate a trunk? Oh, sorry. What are the frame tagging protocols used on a trunk? What are the frame tagging protocols used on a trunk? You get it? Frame tagging is a process of adding tags. Without the tag, how will the receiver know? VLAN 10 is going, VLAN 20 is going. So a lot of traffic is flowing through the trunk. The receiver has to see the tag and identify, right? What protocol can do this? But simply the switch will not do. There should be some protocol. Can you tell me? No? Have you heard of ISL, inter-switch link? Okay, maybe you've just forgotten. But ISL, and then one more is there. The ISL is outdated. It's Cisco proprietary inter-switch link. The main one is what? Yes.
802.1q.
Very good. Brilliant. Superb.
.1.
Said that IEEE created a standardized tagging protocol called 802.1q. Right? That is what even Cisco is using, because ISL was a flop. That adds a 30 byte information, 26 header, 4 byte trail. So we'll talk about that later, but for now, that's the question. What are the frame tagging protocols in our track? Correct? ISL or .1q? That is what is being used on a trunk. Next, what protocol can be used to automatically negotiate trunk? Next question on trunk. There is another protocol created by Cisco to negotiate the trunk. Two switches can discuss, hey, should we form a trunk or should we form access? That's called negotiation. There is one more protocol. ISL and .1q is for tagging only, identifying traffic. That's it. But to form a trunk, there is a protocol. What you people have told me is on mode. This mode, what we just took, this is manual. No, this is like you type this command on both the sides, trunk will form. But I don't want that. I want two switches to converse, talk to each other, and decide whether they can negotiate certain paths. They'll check their compatibility. Are we ready to form trunk or not? If you're not ready to form trunk, we'll settle down to access. You know that. Do you know the protocol?
It's DTP, yes. Dynamic Trunking Protocol.
Oh, very good. Excellent. Good. That is fantastic. Again, Dynamic Trunking Protocol is a protocol developed by Cisco to negotiate the trunk connection between switches. That's very good answer. Excellent. So you must go through all these things at the CCN level. Have a fundamental understanding about this. See, always remember, nothing can be fully taught in any class, but even books cannot teach you fully everything, right? But there should be, these questions help you understand what you're lagging. Are you getting what I'm saying? So when you take exam related questions or interview related questions, you get to know where you're lagging behind. So these are some of the questions you have to ask yourself before getting into the NP program, right? So good. Frame tagging protocols, ISL.1q, which we'll be discussing. How to negotiate a trunk DTP, I will discuss. Just give you highlights here. Okay. So next, again, about these are all trunk related questions. What feature can be used on trunk links to conserve bandwidth? Yes. Trunk links have bandwidth. Every connection has bandwidth, right? A lot of VLANs are going into the trunk. And that is why bandwidth usage is very high. I want to conserve it. I want to save it. Which feature can I use? Again, Cisco developed a feature that can be used to save bandwidth trunk. These are all three trunk related questions. Yes, tell me quickly. Time is. What feature can be used on trunk links to save bandwidth, to preserve bandwidth? Yes, Dilip? No? Have you heard of VTP pruning? Pruning? VTP, forget pruning. VTP, have you heard? Yeah, good. What is VTP full form? Virtual VLAN trunking protocol. VLAN trunking protocol? Yes or no? So that is the answer to the second question. What protocol can be used to sync VLAN information across switches? What is VTP all about? That is the answer to that question. VTP is a protocol again created by Cisco. Other companies have their own version. We'll discuss that. So VTP was created to what? To make sure VLANs that you create on one switch is in sync with other switches in the network. Yes or no? You experience that, right, in your lab. You create VLANs on one switch, automatically it will migrate to other. That is VTP. So there is a technique called VTP pruning in the VTP, which saves what? Bandwidth of trunk. So you want to conserve the bandwidth of trunk links. We use a technique called VTP pruning. Pruning helps us in that. Okay, so you should have an awareness of VTP pruning. You should know what VTP is. What parameter keeps track of the changes made to the VLAN database? We are creating VLANs, we are removing VLANs. Right? VLAN number, no VLAN number. VLAN, no, correct, no, we change the name of the VLAN, etc. So can you give me a parameter that keeps track of the changes made to the VLAN database? In the sense, it will keep track of it. So it's a number basically. What I'm talking about is a number. So if you create 5 VLANs, it will show value as 5. If you remove 5 VLANs, it will show value as 10. it will only increase. How many changes you have made? 5 you created, 5 you removed. So the value answer will be 10. It's not going to minus. Always remember there is a number inside your in the switch which is implementing BTP, which keeps track of the changes that you make. Changes means adding, removing, etc. Every time I create a VLAN 10, number will be VLAN 20, 2, 3, like that. You remove, again it will increase. What is that? Yes. Yes, Dilip. Yes. Tell me fast. No? That's why just revise. This is just a class to make you understand, come prepared, revising something, VLANs, etc. All these. Have a good recap on it. And nobody can know everything, but at least have some understanding. This is configuration revision is the answer, CR. The answer is there is something called CR. Check this out. So if I had a switch with me, command line interface, and if I log into my switch here, if I do show VTP status, you can see that value here. Can you see this? We have this value here called the CR, configuration revision. As of now, it's 0. Can you see that? And that's 0. There is no VLAN configured on the switch. There's no changes made to the database. I'm going to create a VLAN, and you see that number increase. I'm just going to create a VLAN, VLAN 10, because for my lab, I need to create VLANs, right? 2 VLANs I've created. What is the CR value? 2, because 2 changes you have made. See, every time you create a VLAN. Now let's go remove it. Let's go. Okay, let's create one more VLAN. VLAN 1, 2, 3. What is the CR value? 3. 1 VLAN, 3. 2 plus 1, 3. Correct. Now let's remove. I don't need VLAN 1, 2, 3. I'm going to remove it. No VLAN 1, 2, 3. Okay, let's just go get rid of that. No VLAN 1, 2. Enter. I've just removed it. Show VLAN, show VTP status. CR value is increasing 4 because you made 3 additions, 1 subtraction. CR is just increasing. So this is the answer to the question. What is the parameter that keeps track of the changes made to the VLAN database? You get it? So I hope you got the logic towards this, right? Now, coming back to our implementation here, we have to finish our lab here. So we need to build a trunk here. Correct. We need to create VLANs here. So we have our notepad. We are building it slowly. So our L3 configuration is this. We have created the VLANs. We've enabled routing capability, right? We have set up the SPIs as required. We're going to set up the trunk. Correct. So some models will actually force you to specify switch port, trunk encapsulation. It will tell you what tagging protocol. You have to type this command. Some models. So I don't know about this. I'll check it. Switch port, trunk encapsulation, what tagging protocol you want. So you want to build a trunk. You have to specify what tagging method you want, .1q or ISL. Just write .1q. Got it? .1 is preferred. So let's just try this command out. Okay, let's just try this out on this model. Again, the top command may not be required in every, but I'm just trying this out. Paste it. Yeah, it's not XM. So that means by default it is .1q. By default is .1q. But there is a command like that. Don't think there's no command like that just because it didn't work, right? It's just that by default, there is a .1q tagging mechanism enabled. So now we have enabled trunk here. So the lights are turning amber, right? It's setting up trunk, but only one side is not enabling trunk is not enough. You have to go do it on the other end also, right? Other end also. So what was the other end? Sorry. Let's see. Port number 4, right? Okay. Please make sure packet tracer sometimes fools us. Is it 4 or 6? Move it. Yeah, it's 4. Right? It's 4. Right. So let's just, yeah. So port number 4 is the thing. So that's F0 fast Ethernet port. And there is, yeah, let's just see the port number 4, right? Okay. So you have to make both the ends trunk. Then only it'll be a perfect. You can't make one side access, one side trunk. It's a broken link. Broken link. Traffic will not flow. So we do the same command at the other end, L2N. So this is my L2S, okay? L2 switch. Pure L2 switch. Interface port number 4, switch port mode, trunk, done. So we have a beautiful trunk ready to carry VLAN 10 and 20. But how do I know it is ready to carry VLAN 10 and 20? Show INT trunk. If I do this command, you can see that the VLANs allowed is 10 and 20. By default, one is a default VLAN, right? So you can't prune that. You can't remove that also. VLAN 1 cannot be pruned. When you study pruning, you'll see that. But 10 and 20 is being allowed. Can you see that? There is support for all VLANs up to 1005. Can you see? In some models, you have up to extended range also. So this is packet tracer. You can see that? So it's ready to carry. So on both the ends, you can test this command show INT trunk to see is the trunk ready to carry or not. There you go. I can carry 10 VLANs allowed and active in the management domain. You can see that? VLANs allowed and active. Can you see that option? This option indicates that we can carry the 2 VLANs. So the trunk is perfectly ready now, right? Now the PCs must be put into the respective VLAN. I have not done any VLAN implementation. Yeah. So probably this is, I'll just see the ports. Okay. Let's just see the the ports. Port number 1, and this is port number 1, 2, 3. This is port number 3, and this is port number 6. Okay, 1, 2, 3, 6. So let's do that. Yeah, 1, 2, 3, 6. So let's put the ports according. Okay, so let's finish this. So you have to have an idea on how to build. So port number 1 and port number 2, port number 1, port number 2, port number 3 and 6. Port number 3, and we have port number 6. Port number 4 is already configured as trunk. Yeah. So 1, 2, 3, 6. Yeah, there you go. Right. So you know the commands on VLANs. Please practice this lab if you can today. This design create some VLAN like this. Build an L3 switch, L3 to L2, make a connection and see intervene. Simple lab. Because you'll get more dangerous labs later. Got it? So do this simple and get ready. Right. So let's go to port number 1 and 2, program it. You know the command. What is the command? How to put these 2 ports into the VLAN. Port number 1 to range command, then switch port, mode, access, very good, switch port, access VLAN, access VLAN 10, very good, excellent. Switch port, access VLAN 10, done. The moment you do this, these 2 ports, you can see the lights turning amber. They are being configured in VLAN 10, right? And then other set of ports. What are the other ports? Port number 3, comma, not a hyphen now. Can you see? I've used a comma, not a hyphen. Here I used a hyphen, 1 to 2. Here, if I use 3-6 means what? 3, 4, 5, 6. That trunk will go away. So be very careful and see the F I have repeated. Can you see? Here I have not used the F. Only once I've used the F. So the syntax should be very clear. Switch port mode access, switch port access VLAN 20. Then, so now these ports have been programmed. How do you verify whether these ports have been put into the correct VLAN? Show VLAN brief. The switches maintain a VLAN database in the flash memory called VLAN.dat file. So this, can you see? Is it correct? What we did? The VLAN database has now registered the ports correctly, right? So we have done all the required settings on the L2 switch. L2 switch is simple. It's just put the ports into the correct VLAN, make a trunk, finish. L3, you have to build SVI. That's a famous question, right? You need to make sure you have SVIs built. You have to create the VLANs, you have to build the SVIs, and then build the trunk. So all this has been set. So we can expect inter-VLAN now, right? We can expect traffic to move from this VLAN to this VLAN. So let me just see if I have IPs and all configured in. Yeah. So there is an IP, but there's something missing. The gateway. Now, who's the gateway here? The L3. Remember, the L3 is the gateway for the VLANs. It allows one VLAN. See, please remember, it's a hairpin. No? So you have to enter the L3 and come back through the L3. No? Come out of the L3. So you have to give the IP address of the L3 switch. But you are in which VLAN? VLAN 10. So you have to give the IP address of the SVI 10. L3 has now 2 SVIs. Switch virtual. We have created. See, what we have done is we have built 2 virtual interfaces on the SVI. Inside this, there are 2 logical interfaces created. So one is called SVI 10, other one is called SVI 20. SVI 10, what is the IP we have given? We have given the IP 192.168.10.1, and the other one we have given the IP. Yes. So your PCs must have this gateway information configured 192.168.20.1. See, this is the 2 SVIs that are part of this L3, which we configure through commands, right? So now we log into our PCs and ensure the gateway either through DHCP or I didn't have a DHCP. I'm doing it through static, right? So later we'll do advanced 192.168.10.1. Make sure all your machines in your campus have the correct gateway configured, right? The yellow guys will be in, yeah, they will connect to 20.1. They will connect to the 20.1. 20.1, yes. So we should expect a proper inter-VLAN by now. Oh, sorry. 20.20, 192.168.20.1. Okay, that's 20. Let me just see if I made any mistake. Yeah, good. So all IP set, L2 set, L3 set. Everything is set. So we just have to remember only this aspect. Right now, let's check the routing table. The routing table would have got updated because it's basically now maintained. Because without routing table, it cannot show IP route. It will show both the SVIs in the routing table. There you go. It's saying I'm connected to the network 10.0.20. I can move traffic. I can route traffic from 10 to 20. That's the proof. Can you see the routing table? So make sure you log into your SVI, check the routing table. Also check your SVI status. See, if SVI status is up, that's why it came into the routing table. You got it, no? And always make it a habit to see the SVI status up. Can you see that? Previously it was up, down, no VLANs were there. SVI status, you have to see, routing table, you have to see all this here. So make sure when you're doing troubleshooting, right? The two basic troubleshooting commands on an L3 switch for this inter-VLAN is show IP interface brief, check for SVIs, and show IP route. You should verify what? Verify SVI, switch virtual interface, correct? Verify SVI status. Are you understanding this? This one, verify SVI status. Show IP interface brief. Because if the SVI is down, the routing entry will not come up. Will not come up. Are you getting? So let's see if the communication is happening or not. I want to move traffic from the pink to the yellow. One more time. That could be an ARP delay. One more time. Beautiful. Can you see that?
Yes.
The initial delay is an ARP delay, right? So it's working. Let's see the simulation in effect. So is it going through the L3 or not? Is it going through the L3 or not? Yes, it must go through the L3. And I see it's reaching the L3. L3 checks the routing table, finds that, oh, I know how to reach 20 series. It will rotate back, reaches there. And again, reply is coming, go through the L3 and come back. Same experience that you had with routers. I'm just doing it with L3. Same, only with L3. How to do it with an L3? Right? Because L3s are faster than routers. They are replaced now. Routers have completely been replaced by L3. You will not find routers inside the distribution layer today. See, this position of this L3 device is called the distribution point, which we'll talk about the hierarchy. So yeah. So if you look at this, we were talking now VLAN technology we discussed, right? Port security, you have done it, right? You have implemented port security that allows you to register certain MAC addresses. You build a MAC address into the switch, and the switch will look at the MAC addresses before allowing you. If you try to connect, if you're not in the list, you're blocked, which we'll be seeing later. IGMP, snooping, CGMP, maybe higher studies, advanced routing or etc. There you will cover that. Multicasting or routing. Usually routing we will do multicasting. Right? But remember, switch cannot multicast by default. Never think that. If you send multicast to switch, it will send to no. It will broadcast. It doesn't know how to handle until you implement this. Last, snooping. DHCP snooping. Anybody knows this? Anybody knows? The L2 switch can have another feature built in. I mean, you can program it to DHCP snooping. Anybody? DHCP you all know. There's a process of giving IP addresses to devices. Now, this process of giving IP addresses has been, what does that say? Has been manipulated by hackers. A server can give IP to, why can't a hacker give IP to you? Hackers have a lot of tools, programs, etc. It's so easy to set up a DHCP service on your machine and give IP to full NH. Can you not? Imagine now you have set up a DHCP service on your laptop, ran a tool or something, right? And given out IP addresses to the complete NH machine, every single body. What will happen? What is the benefit of doing that? Everybody gets IP. And there's a gateway, no? You'll also specify a gateway. Gateway, you're pointing to your laptop. You're giving yourself as the gateway. What will happen? So all sorts of communication will flow via your thing, the email transactions, every single thing. So what can happen then? You can eavesdrop. Eavesdrop means you can try to capture people's traffic, unauthorized. Now, it will be encrypted. So you have to have other tools to decrypt. It's not easy. It's easy to say, yeah, run DHCP, give everybody IP, etc. But hackers do this. Hackers tend to create rogue DHCPs. Those are called rogues. Rogues are unauthorized DHCP servers. DHCP servers who are not legitimate, opposite of legitimate. Legitimate is the authorized, the one who's supposed to give you IP. So what hackers can do is they can perform something called a DOS, denial of service attack. A DOS attack on a legitimate server. Stop him. I stop him, then I will pretend, impersonate as what? A rogue. And then I start giving out IP. L2 can stop that. We will study that. You'll study that in the CCNP switches. And L2 switch has the brains to actually stop a DHCP attack. This is nothing but a DHCP snooping is a feature to stop this attack on DHCP. It prevents hackers from giving IPs to the network. You got it what I'm saying? Another brilliant feature of L2. So a lot of cool things with this L2 switch, from STP to VLAN to port security to snooping, two kinds of snooping, IGMP snooping, DHCP snooping, having this fantastic MAC table. So everybody hungry, huh? Yes, ready to go. But just give me 5 minutes and then see, these are some commands. These are some commands that allow you to see the MAC table, also called the CAM table. MAC is also known as by the other name CAM because it's stored in the CAM. That's a CAM. It's a memory, right? Show MAC address table is the command that allows you to see the MAC table. That is true. But there are other interesting commands out there, right? What does the second command do according to you? It will allow you to see the particular entry. See, sometimes MAC table will be huge. I don't want to, if you do the first command, you'll see all the entries. I want to filter. I want to see only specific entries. So I could do something like this. Show MAC address table interface. I could do this command. See this? So I could just log into my switch, right? So it's got this additional command after the show MAC address table. will show me the complete MAC table. But show MAC address table followed by the interface. See, I want to see a particular interface's MAC address. I want to see what is the MAC address associated with a particular interface. Can you see? It just shows you the particular interface. Easy commands. I'm just saying, learn how to see the full table, learn how to see specific particular port. What is the MAC address learned on that port? Suppose your manager asks you, okay, this is particular port. Somebody has tried to hack into this port. Can you find the MAC address? It's useful, right? Show MAC address interface, that particular port. You'll find the MAC on which VLAN it belongs, etc. Can you see? Port number 1 belongs to this. Cool, right? Yes. You in any of the thing, you will get these options. Can you see? What are the various options you are available? In the exam perspective, when you're doing labs, CCNP, CCIE labs, you have the freedom to use question mark if you forget. But you should know it also, right? Correct? You should know it, right? You can always, you have the freedom to use the question mark to quickly look into this command. So that's this command. MAC address table dynamic. See, I told you, and static. MAC table can be built manually or dynamically. So before that, look at that. Statically add MAC. Let's jump to this point. Statically add MAC address into MAC table. I can manually add an entry into the MAC table, just like how I do it on router static routing. What is static routing? It's the process of adding a network route manually into the routing table, right? So I could statically add the MAC address into the MAC table. I can do that, right? Why to do it? How to do it? Two big questions. Why and how? First, let's finish the how part. The how part is, this is a command. MAC address table static in red. Specify the MAC address that you want to add, specify the VLAN number, specify the entry, because MAC, an entry in the MAC table contains 3 major records. What are the 3 records? MAC, VLAN number, interface. You have to specify these 3 values, then an entry is added. Let's try that out. See, watch now. So working with the MAC table is very interesting and important. So I'm back here. I know how to see the MAC table. I know how to see a specific entry. Now watch. Show MAC address. Let's just go conf t. MAC address. The command only is simple. MAC address table. Correct? Static keyword. Right? Static keyword. And then you specify the MAC you want to add. Let's say I want to add a MAC 777, 777, 77, something like this. I want to add a MAC 777 forcibly into the MAC table. But why will see this one? I need to specify in which VLAN this particular MAC address will be registered. I want to put it in VLAN maybe 10 or something. Got it? And I want to associate it to an interface. I want to link it to an interface, let us say port number 1. See, it is accepted the command. 3 entries you have to add. You have to specify the MAC, which VLAN and which interface. Now I'll go check my MAC table out. Show MAC address table. I should see a static entry coming into the picture. Can you see that? So you have to learn how to add entries and how to remove. No, that you know, right? Anything you want to remove in a Cisco device or almost any network product is a no. But see, I've added the entry. I would like to see only the static entries, the big MAC table. Think about hundreds of entries. I want to see only static entries. I can type what? Static. See, it shows only static. I want to see only dynamic entries. Dynamic entries. It shows me only dynamic. Can you see? Cool, right? Simple commands. This is just to cut short. Just to make sure you can have a trimmed down version of your MAC table. See what you want to see. Correct? Not rather than seeing the whole table. Now, the big question is why? What is the benefit of manually adding? Okay, look at the benefit. Static MAC entries reduce or control broadcast traffic because of no aging. This entry will not age. This entry will be there forever. Till you remove it. By default, what did we study in the beginning, guys? The MAC table entries will be flushed automatically, right? But static entries will never go away. They will live in the table till their death. They will remove. I'm in the table forever. You have to remove me. It will not go away. The static entry will always be in the table. So what is the benefit of putting a static entry? As long as, usually for servers and all, no? If you know the servers MAC, printers MAC, they're all fixed devices, no? They're not always moving on. Laptops and all, people don't add because they're always moving from one connection to another connection. Servers are fixed devices. Fixed devices, they'll always put the MAC address in the table. So what is the benefit? Is that you actually reduce the traffic broadcaster. Why? Because a switch without a MAC table, if there's no entry, what will the switch do? Imagine if you have a server, very important server, okay? If you have not put the MAC address into this, every time you log in, every Monday, every day you come, you log in, what's going to happen? Broadcast traffic will be generated. But if you register the server's entry, every time you want to kind of switch knows how to reach the server now. So in scenarios where you want to make sure the switch doesn't generate broadcast traffic, you want to control the traffic, you can add the entry. You get it? Very useful. This is fixed devices. And you're sure this device is not going, it's going to be connected to port number 5. I know for sure. It's not going to be moved. Statically add. So that it doesn't age out. Right? Now the next one. Prevent mobility. Locking a device. This is another cool thing. The moment I put my laptop, I added manually to port number 5. I removed the wire, I connect to port number 6. It will not work. You're disabling mobility. Another cool. It's a security feature, right? You can prevent your machine from moving around, mobility. You're locking. You are registered to this port. Can you be in Dubai and Singapore at the same time? No, right? You can't. You can only be in one place. The same thing. This particular machine, you're registered to a particular port, right? You cannot move around. Are you getting what I'm saying? You cannot move around. Are you getting? You're preventing mobility. One way of adding entries into the MAC table. You get the idea what I'm saying? Static entry will always overrule dynamic. What if you have manually added, and or what if there's already a dynamic entry? Means my laptop was connected to port number 2. The switch learned me port number 2. Later, I went and connected to port number 5 where there's a static entry. What will happen? Static is always going to override the dynamic. Static is manual. No. Manual is always going to bypass dynamics. Just like static routing, dynamic routing. When you in a routing environment, you have done static routing and dynamic routing. Which one will take effect? You have run OSPF in your router. You have done static. There's a network you want to reach. You have done both static and OSPF. Which one? Which one will the router prefer? Static route or OSPF route? Static. A manual entry is always preferred over a dynamic. It applies same thing for a Mac. If there is a conflict, there is a static and a dynamic. Switch will always prefer static records. It will ignore dynamic. You say, I don't want to see the dynamic. Static. Right? Additional static dynamic can be learned on a statically configured port. What does that mean? Is additional static or dynamic entries can be learned. Means you can further entries, any sort of additional in a particular port, right? Now I have registered. Now, for example, I've registered my laptop to port number. It's like registration. I am connected to port number 5. You can only connect here, nowhere else. It's not only me. I can register other people also to that port. It's not just one person registered to the port. See, that's what it means. See this? Can you check this out? I have right now show MAC address table. I have registered this 777 to port number 1, right? Can I register another MAC to the same port? Yes, you can. Check this out. See this? I'm going to register another MAC, maybe 777A. Can you see this? Will it overwrite? No, it's an additional entry. Can you see? That means 2 people can now use that port. That is what it means. Are you understanding what I'm trying to highlight here? Correct? So now you understood what is the use of manually adding the MAC table, how to do it, why to do it, right? And these 2 commands are okay. This is to see, just like you're seeing, I want to know who all are there in VLAN. Find out all the MAC addresses in this particular VLAN. So if you're logged into your switch and see in VLAN, I want to see in VLAN 10, how many MAC addresses or how many devices. Okay, this packet tracer doesn't support that. Yeah, it's not supporting the VLAN keyboard. Likely we'll be using evng. Evng, there you will get all this, right? Evng, all these commands you can test. VLAN number. Let's see, I want to see a particular address also. I want to see a particular, you know the MAC address. Suppose you know the MAC address. You want to know which port is connected to. You understand, right? See, you know the MAC address of some. I want to know which port. You can use the address keyword followed by the MAC. Are you getting? You can find. It's all about entries. You know, you're just filtering the entries. It's again, this command will not work in packet tracer because of the fact that it's packet tracer is limited with only these commands. Can you see? Question mark. So, however, these commands can be tested in your Eve application. See, yeah, this one. In your Eve application. I'm done. Okay, I'm done. Just a second. Yeah, so we just quickly see that Eve. So please try to install today Evng. Get it done. Okay, this is how it will be. You will have a VMware workstation installed in your laptop or any hypervisor you can use. So VMware have a Eve is running in Ubuntu. Okay, it runs in Ubuntu OS. It's already built in. So they'll give you an image. Yeah, like this it will load. You'll get an IP address like this. You should get an IP address. Some IP like this. After you install this IP, you can paste it on your browser and start working. He'll show you. Just go to the admin today. 157, 128. So just try to log in to 157, 128. Okay. .168.157.128. So after you install Eve NG, it's far superior, 10 times more superior than packet. Packet is a simulator. This is an emulator. Okay, it does the real thing, real OS you're loading. Packet is an imitation, no? Simulator we call it. Did I make a mistake? 172, 192, 168, 157, 128. Okay, let's just, sometimes you get this kind of thing. So you log in. See, the username and password is shown there. Okay, root. You don't have to ask anybody. Root Eve. Okay, root Eve. Yeah, logged in. Okay, let's see. Okay. Let's see, 1 second. Let's see if I'm. This command is to release the IP, DH client pnet0, get a new IP. This will perform the DORA. Okay, discover offer. Pnet0 is not there. Okay, sorry. If up pnet0, done. Yes, so see the discover offer request of DORA has happened. So I got an IP 157. Let's try now one more time. Still doesn't work, then not a problem. Tomorrow we can find that. Let's see one small thing. Yeah. So one second. Yeah, I'll do one thing. Just show you. So I got other. Okay. Let's just see if I can just see this. Please. Yeah. So this is how the EVNG would be. There you go. Can you see? This is how the EVNG would be. Can you see that? So you can actually load. You'll see. He'll show you everything. Don't worry. Don't waste time. But this is how it's going to be. You type in IP, you'll get this browser kind of view, beautiful view. You can log in. So I'm logging into an L3. There you go. Which packet traces, several commands don't work here. Right? I just want to show you the show MAC address table. So if you look at this, you can test that all these commands. Okay, show MAC address table. Sorry. Yeah. Question mark. Can you see? I got far more commands to test. Just a second. Yeah. So you can just see this. So we can use EVNG, which we'll be using to make sure it's done. It's slow internet, you know. Okay, no problem, guys. So we'll end it here for today, right? So do you have any doubts so far? Because tomorrow, make sure you just have a brief understanding about this, right? So tomorrow we will continue. We'll be talking mainly tomorrow about, we'll go further discussing switches, how they work, the architecture and all those things. So you just make sure you just practice this lab once, study VLAN, just go through VLANs once. Just go through VLAN, go through STP, these two topics, just basics. We are trying to do one L3 to perfect, you do that. Then we can build, because our goal will be to build an architecture, okay? Access distribution core in need for that, full setup, okay? So make sure you know this. Fine, I'll end it here. Fine, thank you, guys. Thank you, okay?